Bismillahirrahmanirrahim. It's me Sabah Said and I'm here with a new topic of distance and displacement, speed and velocity and acceleration. It's the second lecture of chapter number 2 of class 9th physics for Punjab textbook board which are used by FBISE. Here, what is position? To discuss distance and displacement, first of all, we have to know about the position. What is position? The term position describes the location of a place or a point with respect to some reference point called its origin. For example, you want to describe the position of your school from your home. Let the school be represented by S and home by H. The position of your school from your home will be represented by a straight line HS in the direction from H to S. Here in this picture you can see your school is represented by H and your house is represented by H and your school is represented by S, and a red line show the distance from house to school, and H is the position of house and S is the position of school. Distance and displacement. Length of a path between two points is called the distance between those points. Displacement is the shortest distance between two points which has magnitude and direction. Here you can see a ladybird which is flying, and you can see its flight with a red arrow and a blue line. The red arrow representing the displacement of the flight and blue line representing the distance of his flight. Let S be the length of a curved path between two points A and B on it. Then S is the distance between point A and B. Here in this picture you can see a blue line showing the distance between point A and B. It is represented by small s. Consider a body that moves from point A to B along the curved path. Join points A and B by a straight line. The straight line AB gives the distance which is the shortest between point A and B. This shortest distance has magnitude d and direction from point A to B. This shortest distance d in a particular direction is called displacement. It is a vector quantity and is represented by d. Here in this picture you can see a red arrow which is showing the direction from point A to B, and it is a displacement from point A to B, and it is represented by small d. Displacement have some particular direction and it is a vector quantity which is not present in distance. Distance don't have some particular direction and it is scalar quantity. Here's the difference between distance and displacement. The first property is its definition. The complete length of a path between any two points is called the distance. Displacement is the direct length between any two points when measured along the minimum path between them. Distance is denoted by d and displacement is denoted by s. To calculate distance, the direction is not considered, while to calculate displacement, the direction is taken into consideration. Distance is a scalar quantity as it only depends upon the magnitude and not the direction. Displacement is a vector quantity as it depends upon both magnitude and direction. Distance gives the detailed route information that is followed while traveling from one point to another, while displacement refers the shortest path. It does not give complete information on the route. The formula for distance is speed into time, while the formula for displacement is velocity into time. The distance can only have positive values. Displacement can be positive, negative, and even zero. Speed. What is speed? The distance covered by an object in unit time is called its speed. Speed of an object is the rate at which it is moving. In other words, the distance moved by an object in unit time is its speed. Unit time may be a second, an hour, a day, or a year. Here s is the distance covered by the object, v is its speed, and t is the time taken by it. Distance is a scalar, therefore speed is also a scalar. SI unit of speed is meter per second. Here in this formula you can see that distance covered divided by time taken is equal to speed. For distance, speed multiply time is give us distance. So distance is represented by s, speed is represented by small v, and time is represented by small t, which multiplication of small v and t give us s, which is distance. Uniform speed. What is meant by uniform speed? When a body has uniform speed if it covers equal distance in equal interval of time, however short the interval may be. Here in this picture you can see a car is moving and it is covering distance in miles, and it is covering equal distance in equal interval of time, so the speed of car is uniform. For example, a car is covering 1 mile in 5 seconds, 2 mile in 10 seconds, or similarly when it covers equal distance in equal interval of time, then it would be uniform speed. Velocity. The rate of displacement of a body is called its velocity. The velocity tells us not only the speed of a body but also the direction along which the body is moving. Velocity of a body is a vector quantity. It is equal to the displacement of a body in unit time. Here, displacement divided by time taken is equal to the velocity. Here, displacement is a vector quantity, so velocity is also a vector quantity. And its formula is, when velocity is represented by small v, displacement is represented by small d, and time is represented by small t, then velocity is equal to d by t, and displacement is equal to v into t. Here d is the displacement of a body moving with the velocity small v in time t. SI unit of velocity is the same as speed, that is meter per second. Uniform velocity. Let's talk about uniform velocity. Here in above equation you have looked about v is the average velocity of a body during time t. It is because the velocity of body may be changing during the time interval t. However, in many cases the speed and direction of a body does not change. In such a case, the body possesses uniform velocity. This is the velocity of a body during any interval of time has the same magnitude and direction. Thus, a body has uniform velocity if it covers equal displacement in equal interval of time, however short the interval may be. For a body which cover equal distance in equal interval of time, that is uniform speed, and if a body cover equal displacement in equal interval of time, then it is uniform velocity. Here in this picture you can see a train is covering equal displacement in equal interval of time, then it would be called as uniform velocity of the train. Now here's the difference between the properties of velocity and speed. First of all, velocity can be defined as the rate at which an object changes position in a certain direction, while speed is the rate at which an object covers a certain distance is known as speed. Velocity is a vector quantity while speed is a scalar quantity. Velocity can be zero, negative or positive like displacement, while speed can never be negative or zero like distance. The velocity of the object changes with the change in direction, therefore the object must follow one direction, while speed, for average speed, will continue the count even if the object changes direction. An object may possess different velocities but the same speed because of changing direction. So for the speed may or may not be equal to velocity. Velocity is measured in meter per second. Similarly, speed is also measured in meter per second. For velocity, v is equal to delta x over delta t, where v is the average velocity, delta t is time interval, and delta x is the displacement. For speed, v is equal to small t over small t, where small v is the average speed, T is time taken to travel the distance, and D is the distance traveled. Acceleration. Basically, acceleration is defined as the rate of change of velocity of a body. The average acceleration of a body given in above equation is during time. Let's the time t is divided into many small intervals of time. If the rate of change of velocity during all these intervals remain constant, then the acceleration also remains constant. Such a body is said to possess uniform acceleration. Here in this formula you can see change in velocity over time taken is equal to acceleration. Acceleration is basically final velocity minus initial velocity, which is equal to change in velocity divided by time taken. So acceleration is equal to Vf, which is final velocity, minus Vi, which is initial velocity, over t. In many cases, the velocity of a body changes due to change either in its magnitude or direction or both. The change in the velocity of a body causes acceleration in it. In this picture, you can see a car is moving and the velocity is increasing gradually from 1 to and up to so on, while the acceleration remains constant. The velocity is changing with this constant acceleration, and car is moving gradually with increasing velocity. Certainly some happens to car and it have to stop, and it stopped. There is some deceleration which is known as negative acceleration, and which is opposite in the direction of acceleration. Deceleration is opposite to acceleration and could also be said as negative acceleration. So, taking acceleration as A, initial velocity as Vi, final velocity as Vf, and t is the time interval. SI unit of acceleration is meter per second, which is equal to meter per second square. Uniform acceleration. A body has uniform acceleration if it has equal changes in velocity in equal interval of time. However short the interval may be. A is equal to Vf, which is final velocity, minus Vi, which is initial velocity, over time t. The average acceleration of a body given in above equation is during time t. Let the time t is divided into many small intervals of time. If the rate of change of velocity during all these intervals remain constant, then acceleration A also remains constant. Such a body is said to possess uniform acceleration. Acceleration of a body is positive if the velocity increasing with time. The direction of this acceleration is same in which the body is moving without change in its direction. Acceleration of a body is negative if velocity of the body decreases. The direction of negative acceleration is opposite to the direction in which the body is moving. Negative acceleration is also called deceleration or retardation. Here in this picture you can see blue lines show the velocity of ball and green lines show the acceleration of the ball. When ball is moving, the direction of acceleration and velocity is showing, and when ball slow down, the direction and the velocity is decreasing. And when object is slowing down, the direction of acceleration is opposite to the direction of velocity. Here in this picture you can see the direction of A is opposite to V when object's motion is slowing down. Thanks a lot. Thanks for watching.